The next group of compounds we will talk about brings us to what are called the transition metal compounds. Previously we talked about compounds that are made with metals that come from the first three groups of metals on the periodic table, the alkali metals, the alkali earth metals, and metals found in the boron family. Now we're going to talk about compounds that are made with elements that are found in the D block, as well as metals that are found in group 4, the carbon family. The reason we treat these separately is because these compounds are unusual. The fact that these have variable oxidation numbers. The metals in the carbon family are tin and lead. Well, why do these have variable oxidation numbers? These metals we find use all, some, or none of their d electrons as valence electrons. These are not their normal valence electrons. All of these elements technically have two valence electrons. Their outermost shell, the distance farther from the nucleus, is always the s and p, or in this case, since there's no p in most of them, it's s. But they have this ability, to take these d electrons and give them away, just like they do with their normal valence electrons. Now the interesting thing is they don't give the same number away every single time. So this is what we mean by the term variable oxidation numbers. That means that each element can have more than one oxidation number. So for example, copper is either +1 or +2. Sometimes it gives away one valence electron, and sometimes it gives away 2 electrons as valence electrons. Iron, Fe, is +2 or +3, which means that sometimes iron gives away 2 electrons and sometimes iron gives away 3 electrons. Now there are very few important exceptions. Silver is always +1. And zinc is always +2. So I suggest that on your periodic tables here, you write somewhere, these are the only two transition metals that have one oxidation state, just like the rest of the metals do. All the rest of them have a lot of different ones. Now we don't just write all over our periodic table, because some of them have a lot, like vanadium has +2, M +3, M +4, M +5. It has 4 different oxidation states that it can have, depending on how many valence electrons it gave away. So there has to be a better way of keeping track of these. So how do we look at a compound and tell, for the transition metal, well, what oxidation state does it have? For these compounds, we will see something different in the name. It will be a Roman numeral to show the oxidation number or the oxidation state of the transition metal. Now some of you may or may not remember your Roman numerals. 1, 2, 3, 4, 5, 6, 7. That's as hard as we're going to need to go. Giving away the oxidation state of 7 means that they gave away 7 electrons as valence electrons. That's a lot. We don't find too many elements that do that many electrons, but you will see occasionally +7. That's as high as you're going to need to go. Don't get 4 and 6 confused. Students tend to do that. 4 and 6. Remember 1, 2, 3, and then here you replace, so when you go from 3 to 4, replace the last 2 with the V. So this is 4 and this is 6. Don't get them mixed up because they mean 2 different things. Okay, so how does that work? So if I write copper, Roman numeral 1, oxide. That means that this part right here means that the copper has the oxidation state of +1. Now what about the oxygen? Well, it's just a regular nonmetal. Nonmetals only have one oxidation state. This unusual behavior is only for the transition metals. So this means this is just O-2, just like normal. So then, using what we learned from the last lesson, which is switching, this is sometimes called the crisscross method, we're going to say 1 and 2, so the formula is going to become Cu2O1. We just don't write the 1. Okay, let's look at another example. Iron, okay, so how do we write the formula for iron 3 phosphide? Well, don't forget that this piece right here means Fe plus 3. Okay, phosphide, this would be the element, the ion for phosphorus. So that would be P, and phosphorus has an oxidation number of -3. Now, as we learned when we talked about simple ionic compounds, they're still going to add up to 0. They're still ionic compounds, so they still obey all of the regular rules. So +3 and -3, those will add up to 0, so I don't only need one Fe and one P. Okay, so how do I go the other direction? How do you look at a formula? Let's go back to here. How do you look at the formula and figure out, well, what is the Roman numeral? The challenge to these is that you can't look up the oxidation numbers on the periodic table. You can look up any nonmetal. You can look up the alkali metals, alkali earth metals, or the boron family metals. The transition metals, you can't. Alright, so let's look at this compound. How are we going to write the name for this? Well, the metal's still going to come first. We're going to look at the periodic table and say, okay, what's Sn? Okay, look, Sn is right here, Sn. Okay, Sn is in the carbon family, so that means that Sn is going to have a Roman numeral. Sn is 10, so I'm going to write down the name. Okay, and I'm going to have to put a Roman numeral into the name. Inside the parentheses, there's going to be Roman numeral. I'm going to come back to that. Right now I'm going to leave it blank, and I'm going to figure out what Roman numeral is. Let's name this piece. This is the fluorine ion. So remember, the nonmetal ions become IDE. So this is 10, some Roman numeral, fluoride. Now for these compounds, when you look at a compound that has a transition metal or one of the metals from the carbon family, this is kind of called the reverse crisscross. You say, okay, I know that the numbers in the formula are written in reverse order from the oxidation numbers. So that means that there was 1 10 and 4 fluorines. That meant that the oxidation number on the 10 had to be the 4 and the fluorine had to be the -1. So this right here, that tells me that the Roman numeral to go inside the parentheses is a 4. Okay, let's do another example. Okay, Mn2O7. Okay, Mn is right here. Manganese. Remember what I said? Do not confuse manganese and magnesium. They sort of look and sound the same. They both start with M, but they have different symbols and they're totally different elements. So if you write Mg when it's supposed to be Mn, that isn't going to work. Okay, so I know this is called manganese. It's a transition metal, so I will have to have a Roman numeral in the name. I don't know what the Roman numeral is yet, so I'm just going to put the parentheses and leave it blank. Okay, this is O, so that's oxygen ion, which is oxide. Okay, now to figure out the Roman numeral, let's go back and take a look at the formula. Look at the order. It's 2, 7, which means that the oxidation numbers were in the opposite order. So this had to be 7. And this had to be the 2. So that's the metal, so it's positive, and that's the non-metal, so it's negative. So this right here is the oxidation state, which means that this is a Roman numeral 7. Okay, 7, 7. Okay, one more example, and I'm going to let you try this on your own. Okay, Cu is the transition metal, copper. Transition metals have to have a Roman numeral. I'll put the parentheses. And this is the iodine ion. This is called iodide. Okay. Now I look here and I say, well, there's no numbers. So does that mean that it's all ones? Well, in order to, for these, if you don't see any numbers in the formulas, go to the non-metal and look at the periodic table. Okay, right here, iodine, the halogen family, they're all -1. So that means I know that this is -1. Well, since there's 1 copper and 1 iodine, and I know they had to add up to 0, I'll say, well, if this is -1, That one has to be positive 1. So that means that this right here means a Roman numeral 1 goes in the parentheses. I'm going to do one more. Just want to make absolutely sure that you feel comfortable with this. Okay. What's the name of this compound? Okay, capital V. If you go to the periodic table and look up capital V, you'll find it in the transition metals. It's called vanadium. Transition metals need Roman numerals, so here's the parentheses. This is the sulfur ion, S for sulfur. So that means the sulfur ion is called sulfide. There's no Roman numerals. Excuse me, there is no numbers in this formula. So how do I know what the Roman numeral is? Let's go back to the periodic table real quick. Here's sulfur. Sulfur's in the oxygen column, which means that the oxidation state for sulfur, I know, is -2. Okay, well, since there was one vanadium and one sulfur, that means that since they have to cancel out to 0, this has to be a +2 to match up with the -2. So that means that it's a Roman numeral 2 inside the parentheses. So this is called vanadium 2 sulfide.